Hello everyone. Today we'll see one more numerical on reactance diagram and thereby calculating the terminal voltage of the machine. So this is the example. So let me read this. So figure shows the schematic diagram of a radial transmission system. So this is the radial transmission system. Why this is a radial transmission system? Because the load is connected only at one end of the system. Here there is this generator is supplying the load here. So this is a radiating system or radial transmission system. The rating and reactances of the various components are shown thereby. So here itself all the ratings are shown. A load of 60 megawatt at 0.9 per factor lagging is tapped from the 66 kV substation. This is 66 kV substation which is to be maintained at 60 kV. So actually this load is connected to this side of 66 kV transformer or 66 kV substation, you can tell here. The load is connected to the 66 kV side, but the terminal voltage of this load has to be maintained at 60 kV. Calculate the terminal voltage of the machine. So what is the terminal voltage of the machine we have to calculate? So that is V1 we have to calculate. So let us start writing the solution. See, first thing what we need is the reactance diagram. So first we'll write the reactance diagram. So for writing reactance diagram, we know the procedure. So first is the reactance diagram. So for writing reactance diagram, we need all the per unit values, and we need to first decide what is base MVA, base kV of the system. All these things are needed. So let us do that first. See here, the generator ratings are not given. So the per unit reactance value of generator cannot be written since the ratings are not known and also reactance is not known. Now here if you see the transmission line kV, this side transformer is 220 kV and this side is also 220 kV. So we can take the base kV on transmission line as 220 kV itself. So I can write base kV on transmission line. Transmission line is base kV on transmission line is 220 kV. Why I am not deciding kV base here first? Because I don't know the kV of the machine or the machine rating is not known. So I cannot calculate base kV first here. So let us fix this first. Then based on this we can calculate the base kV on the generator side. So base kV on generator side, generator side is low voltage side. So high voltage kV we know. So high voltage kV is 220 into the rating, that is the low voltage rating, it is 11 divided by high voltage rating. So it is 220. So it is 11 kV. So base kV on generator side is 11 kV. Similarly, we will calculate base kV on load side. Load side is on the low voltage side of this transformer. So high voltage kV base is 220. So it is 220 into low voltage rating, that is 66 by high voltage or HT rating. So it is 220 is equal to 66 kV. So we have found all the kV bases. So here it is 220. On the other side of this transformer it is 11 kV. On this side of this transformer it is 66 kV. These are the base kV values. Now base MVA base MVA. It is not given in the question, so you can select any value or you can select the rating of these transformers as the base MVA. So here it is given 100 MVA, so let me take that itself as the base MVA, base MVA. Okay, fine. Next, in order to write the reactance diagram, we'll calculate the reactance value of each and every element in the system one by one. So anyways, this is not given, the rating of generator is not given, so we'll not consider that. We'll start from here. So reactance, that is per unit reactance of, let me take this as T1, reactance of T1, that is transformer T1. So let me take it as XT1 per unit will be equal to, what is the given reactance value? It is 10%. So it is J.1 into MVA base new, that is 100, divided by MVA base old, it is 100, into kV base old. What was the kV base old? You can take either low voltage side or high voltage side. Let me take low voltage side, it is 11, and new kV base which we have decided is also 11 kV whole square. So this is J.1 per unit. Done. Now reactance of transmission line will calculate. So reactance of transmission line, so XTL. Now which equation to be used? Since the reactance value here given is in ohm, we have to go for the other equation, that is J150 ohm, that is the reactance value, into MVA base, new MVA base, divided by new kV base square. So what is the new kV base square? It is 220 square. So the value will be J.31, so J.31 per unit. So this is for transmission line. Next, let us write reactance per unit reactance value for transformer 2. So it is a reactance per unit reactance T2. Let me take that transformer as T2, and it is this. So it is XT2 will be equal to, it is per unit reactance on the machine rating, it is given 8%. So I can take this as J0.08 into MVA new, that is 100, MVA old is also same. So it is 100 because it is given here, it is 100, and kV base old. So you can take either this or this. So let me take 66 low voltage side. So it is 66 square, and kV base new on the same side. So on the low voltage side, kV base is 66, that is new. So it is 66 square. So if I calculate this, this is J0.08 per unit. For load, there is no reactance value given, so let us not write that. Now let us write the reactance diagram for the system. So it is a generator starting. So let me take reactance and the EMF for the generator. So it is AG. Then immediately after generator, we have a transformer here. So let me represent transformer with the reactance. Then after that we have transmission line, so it is a reactance. Then again one more transformer, it is a reactance. Then at the other end we have load. I don't know what is a load here, but we can just represent it with this, or you can write a reactance representation. So this is XG, this is XT1, this is XTL, this is XT2. XT1 is J.1, XT2 is J0.08 per unit, XTL is J.31. So let me write, so it is J.31 3, 1. Now reactance diagram is done. Now what we have to actually calculate, see here it is given, calculate the terminal voltage of the machine. So terminal voltage of the machine is this voltage, it is VGT. Let me take generator terminal voltage, that is VGT. How to calculate VGT? Now you see here the reactance values from here to here, it is known. Do we know the terminal voltage here? If yes, then we can easily calculate VGT. How to calculate VGT? See, let me take this as VL, that is a load terminal voltage, and I'll take the current flowing here as IL. So from this I can write VGT, since it's a generator, VGT is equal to I into VGT is equal to I, here it is IL, IL into the reactances, that is XT1 plus XTL plus XT2 plus this drop. So VGT is equal to this voltage drop, that is I into X. So since all these reactance values are in series, I have written like this, XT1 plus XTL plus XT2. So I into X plus this voltage. So what is this voltage? This is VL. So you can easily calculate VGT. But remember one thing, we have calculated these reactance values in per unit. So all these parameters must also be in per unit. Then the answer what you are getting is also in per unit. Then later we can convert it into voltage. So now before writing or calculating VGT, let me write all these values in per unit. This is already in per unit, but we have to write VL in per unit, and also we have to calculate IL, then IL also in per unit. So what is VL here? See, they said, here it is given, the load has to be maintained at 60 kV. So this is 66 kV transformer low voltage side. To this end the load is connected, but we have to maintain the terminal voltage of the load as 60 kV. So 60 kV is the voltage there, but I have to convert it into per unit value. So VL is equal to 60 kV. How to convert it into per unit value? So VL per unit will be equal to actual value divided by base value. So what is actual value? Actual value is 60 kV. What is base value? Base value in that section. So base value here it is 66 kV. So divide by 66 kV. This gives me 0.909 per unit. So this is a per unit value of VL. So this is done. Now we need IL. So how to calculate IL? IL is this line current over here, or this load current, not line current, so load current. So IL is a load current. So since the load parameters are given, that is 60 megawatt, 0.9 power factor, so we can calculate IL, actual value of IL. So let me calculate IL. So IL is equal to, you can use that power equation. So power, 3-phase power is equal to root 3 VL IL cos phi. Root 3 VL IL cos phi. So IL will be equal to P divided by root 3 VL cos phi. And obviously we have to write the angle of this. Since the power factor is lagging, it is minus, and the angle will be cos inverse of power factor, cos inverse of cos phi. So IL will be equal to power. So what is power there? It is power is 60 megawatt. So it is 60 into 10 to the power 6 divided by root 3 into VL is what? VL is the load voltage or the terminal voltage of this particular load, and it is 60 kV. Don't write per unit value here because we are calculating actual value of current. So it is 60 into 10 to the power 3 into power factor. How much is power factor? It is 0.9. Power factor is given, it is 0.9, and it is lagging, so it is minus cos inverse of 0.9. So if I calculate this, I'll be getting 641.5 at an angle minus 25.84 degree amps. So this is the actual value of the current. So we have found out actual value, but what we need is per unit value. So per unit value of IL in per unit is nothing but IL actual divided by IL base. So how to calculate IL base? So in our previous videos we have seen base current I base can be calculated as 1000 into MVA base divided by root 3 into kV base. So here it is 1000 into MVA is 100 divided by root 3 into kV base, where kV base in that section. So kV base here in this section it is 66 kV. 66. I am not writing 10 to the power 6 and 10 to the power 3 over here because it is already compensated with this 1000. So this gives me 874.77 amps. So this is the base value of current. So let me substitute here. So IL actual is this, that is 641.5 at an angle minus 25.84 divided by 874.77. So this gives me 0.733 at an angle minus 25.84 degree per unit. So this is the per unit value. So we have found all the per unit values. Now it's easy for us to calculate VGT in per unit. Remember, it will be in per unit since all these parameters are in per unit. So VGT per unit will be equal to IL in per unit. So what is IL in per unit? It is 0.733 at an angle minus 25.84 into XT1. So what is XT1? It is J.1. So it is J.1 plus XTL, it is J.31 plus XT2, it is J.08 plus VL. VL is how much per unit value? It is 0.909 per unit. So we have substituted all the values. So if you calculate this, you will be getting 1.112 at an angle 16.87 degree per unit, VGT per unit. But terminal voltage of the machine is asked, so it is always better if you write in voltage or kV. So VGT in kV will be equal to, so per unit value is actual by base. So what is actual value? Actual value, it is per unit into base. So per unit, that is VGT in per unit into base kV. So VGT in per unit is this much. So 1.112 at an angle 16.87 into base kV. Now remember, base kV is not same in all the sections. So base kV here we have to consider, because we are calculating VGT for the generator, that is the terminal voltage of the machine. So what is the base kV for this section? It is 11 kV. So we have to calculate the base kV there. So it is 11 kV. So this will be equal to 12.232 at an angle 16.87 kV. So this is the terminal voltage. Similar way, you can also calculate the low terminal voltage if VGT is known, or if suppose it's a combination of two motors or one motor, you can calculate what is the terminal voltage at the motor side or load side. For that case, we should know the VGT value and also IL and all the reactances value. Thank you.